Hello everyone, welcome to the poster IP coding style variants in a multi-layer generator framework. I'm Johan from Infineon. As we all know, in the hardware development, we need to customize design to perform the required task with minimal area and power assumption. This leads to longer development time and cost. Therefore, hardware generators such are introduced to accelerate the design process and aid intellectual IP reuse. But the IP coding style remains untouched, unflexible. IP coding styles have different aspects, such as file granularity, naming convention, hierarchical granularity, code formatting. This has a direct impact on readability, maintainability of our code, and the synthesize time in the synthesizer and code-based versioning. To enable flexibility in the IP coding style, we introduce our multi-layer hardware generator framework and the responsive and the respective view transformations. So our hardware generator framework has three layers. The first layer is sync layer, which captures the specification formally. And by translating the specification to design, we have the design blueprint already encapsulated in the platform independent design model. Afterwards, target language syntax and platform-specific aspects are considered to generate the view model, and the view model can be later serialized to different hardware description language such as VHDL, Verilog, and System Verilog. If we look at the central stage, the design model here, the design layer here, a design model has different components inside to describe the design. First is descriptive components, which indicates the hierarchy and the description style in the IP coding style. And in every descriptive components, we can have different logic described. Primitive components indicate combinatorial logic. Sequential components indicates register memory. Behavior components can be FSM, which describe the hardware behavior on high level. And by transforming the descriptive components in design model, we can already alternate the description in the backend. And we provide also further transformations. I will give you more information here. So if we look at the descriptive components in our framework, there are two of them, data flow and structure. The example here is a fader, which consists of two half faders inside. If we have it in data flow view, then only the hierarchies are generated. In this case, three hierarchies. But in the structure view, we have more granularity, which means the gates are also generated. But the gate, for example, the AND gates and the XOR gates, they perform. The AND gates perform the same function, and the XOR gate perform also the same function. We introduce further transformations in the file cacher, which analyze the components and reduce the same function HDL file. If we use file cacher here, then the AND gate will be only generated one time and be instantiated two times in the half adder hierarchies. And flatteners is more advanced, which can flatten the hierarchies as instructed. So in this case, if we say that we want to flatten all the hierarchies contains less or equal than 5 components, then the full adder hierarchies will only generate one file, which have all the logic inside. And further, we have also data flow or structural, which transform the description style from structural to view to data flow view or backwards. Furthermore, for the naming convention, we provide also nomenclature, and the user can define the prefix, suffix as they prefer. To demonstrate applicability, the proposed approaches are applied onto industrial RISC-V SoCs. We have different benchmarks here, which is coding style variety, which means that how many files, HDL files, are generated for different SoCs with different transformations. And we also benchmark the check-in time with rational clear case for different backend. Additionally, in the with synthesize tool Vivado, we have benchmarked synthesize time with different IP coding styles. And last but not least, the development effort is also shown for different transformations. Uh, for file cachers, it consumes more than 400 lines of code, which has functionalities like analyze components and analyze characteristics of components and decide whether they are same function, which requires more lines of code. But the nomenclature is rather easy because we just need to go through every hierarchy and go through every components to make the name attribute of the components suit our naming convention. So that's my poster. If you want more information on the results section or any details in our approach, please come to me. Thanks.